Okay, so our next session is another one of these core member thought leadership sessions. For those of you who aren't members of Covisa and want to join at the core level, well, this is one of the benefits of being able to be a core member is to come and give your thoughts and share thought leadership at our all member meetings. And we have the privilege of hearing from Renesas, Munakata-san, and Daniel Cisco. So they're going to tag team on this next session, so it's all yours.
Thank you. So thank you for staying in this room. I'm a bit concerned that people go away, but I'm happy to see the people staying here. And my name is Munakata, and Renesas is a chip company, the hardware company, but I'm unique because I'm working for the software, and also I'm long-term working for the open source. So it's a kind of the maybe enemy in the company, but now many people start thinking about open source importance, so that's a good sign for me. And I'm not talking about anything about the business, but I asked Dan to take over me to talk something small about our Renesas things. So let's start with the software capital. Maybe you're a bit confused because software as a service is a common word, you already know. But software as a capital, maybe this is the first time to see. So I try to introduce my idea bit by bit. So let's start with what I say, the transition of innovation source. That means, especially if you focus on the automotive industry, so I'm a chip guy, and I work with the Tier 1 and also work with the OEM company. So in the past, roughly my feeling is that 10 or 15 years ago, so most of the knowledge is some kind of excellence, design excellence, is to stay in the circuit design, exposed as a PCB layout. That means Tier 1 pick some components, the main SoC and also the external AD converter and the interface IC, to make it a circuit. So that's obviously the Tier 1 role in that time. Then, until recently, that kind of circuit is fit in the chips. That is SoC, system on chip. So that situation caused that the Tier 1 come to us to try to fully understand, fully utilize our SoCs. That was happening in last maybe 5 years. And now, such kind of differentiator is moving to the software. So now many companies, OEM companies start trying to writing the software on behalf of the Tier 1 right now. So this is a very confusing situation for us now because formerly we only need to talk to a Tier 1 company, but now we start talking with OEM as well. And also they are asking about very low-level software to very high-level structure as well. And newly talking about AI and some new stuff. So this is happening right now, and this is a software-first approach, and also they call it software-defined vehicles. So the things happening behind is this transition, PCB, chips, and now software. This is a very important trend happening right now. And I want to say that one size does not fit all. That means Tier 1 and now the OEM companies start writing the code, but they don't need they want to make a different type of code. Just if you make one software does not run on different hardware. Because initially the hardware is different. Because to satisfy each different vehicle requirements, the expensive car, the commercial car, many things. So the hardware performance variant, that means the price variant. So that means you need to write a different software, optimized software for the different stuff. And different expectations for the display numbers and the AI features. So these kind of the very important differentiators for the vehicles. So now they need some hardware variation, also the software variation. So based on now the Android becomes very common in the automotive industry, and still some people running on I'm working on the Covisa and also the AGL. So many people still working on the native Linux and some other stuff. So some software also has some difference. So the right-hand side, you can see that this is Google new idea, GSI, Google Generic System Images. That means in smartphone world, the Google mandate handset vendors to run the exact same binary on different stuff. That, of course, minimizes the validation effort done by the Googles. But this kind of things, the commonality things, not yet happen in automotive industry. So this is a reality. So people are struggling to make a different, similar but different type of software for different products. This is happening right now. So let's think about what type of the software reuse need to be considered. So this is a typical idea. So the OEM A, left side, and OEM B, and also the tier 1 A and the tier 1 B is working together in this case. The first, so the OEM B want to use the same software product come from the tier 1 A and also to come from tier 1 B. But you can easily imagine tier 1 A and the tier 1 B cannot share the code because they are competitors. So if OEM try to provide the application code, that can be the identical, but still the major part of the two box is different. And the next case, the tier 1 A also work for the OEM A. So OEM A and OEM B cannot share the code because of their requirement are different. So tier 1 need to write a different code for the OEM A and OEM B. And tier 1 A is the different team, also working for the OEM B. But even inside the tier 1 A, in many cases, they cannot share the code across the design teams. So this is reality. And the next one is tier 1 B has making some product for the OEM B, but they have different versions, the new generation product. So in many cases, if you, for example, the CY23 model and the CY28 models, they're mostly similar ECU box, but they are not restarting from the scratch. This is the reality happening right now. And the final thing is OEM A and OEM B want to share some part of the code. So this is the motivation of the COBESA and many other industry consortium things, but this is start happening, but not common yet. So as you can see, if you consider about the reusing the software, this is not easy. So this is a reality at this time. So what is a blocker to cause this kind of confusion? So one is the hardware. Because the hardware, the performance is different, the processor speed and memory size, and the CPU processor core numbers, GPU performance, and NPU, the AI things, that kind of thing is different. And the minor IP incompatibility, this is important. Because in our case, Renesas used to be in the past, the generation 3 ARCA device is the ARCA H3, M3, E3. This is the performance variant. But you'd say that this is a family device, you can use the same software, but in reality, our hardware design guy did a minor optimization of each hardware variant. That resulted some breaking the 100% compatibility across even on the ARCA Gen 3 series. So that's what's happening. So this kind of minor IP compatibility is a big burden for the customer to reuse the software because some customers start writing code for ARCA M3, and sometimes they want to make the inexpensive variant using E3. In that case, they cannot use the exact same code. So that kind of burden is happening. And also the IDE, the debugging board is different. But the software side, the number 2 software side is so data definition. Because the COBESA is working with the VSS, vehicle signal specification, because currently the CAN device, CAN message is different and not shared across the OEM. So that resulted. So if you, in the previous slides, tier 1A working with the OEM A and OEM B, they cannot use the same message because they are talking different languages. So some common language is important, and also the coding conventions. So tier 1A and the tier 1B may use the different coding conventions. So it's very hard to share the code. That things are happening. And the business things, so of course, tier 1 and OEM have some the NDA contract, and in some cases, in many cases happening in previous, the tier 1 does not provide the source code to the OEM. And if the OEM want to change the features or something, so they need to ask the tier 1 to release a binary. So that was an industry reality until today. But now, as I mentioned, the OEM also start writing the code. So this kind of code sharing and also licensing and the delivery kind of thing, this kind of management thing also breaking the software reusability. So this is the big headache for us. So today I want to say the software as a capital. In the previous, software considered as an asset. Many tier 1 company release the product to the OEM, the software, so they think that's a software asset. So software asset is some kind of collection of the past working stuff, and I made some pictures. That means each OEM company now collect the many software assets given from the tier one, but they cannot cook that for make the future product because in one case they don't have a source code, and in another case they are very tough to reuse due to the lack of the document and due to the incompatibility thing as I mentioned in public. So this is in the past many companies think the software is just asset, but today I want to say software must be the capital. What's the difference? The software itself is the same thing, but if you consider software as a capital, they must be the source of next product, source of next values. So this is a concept of the economy and the financial guy, but in the past, most of the people are making many various software, but cannot reuse. So today I want to say how we can make software as a reusable things. That's important. Then, so maybe, I don't know how many of you are familiar with the financial world. So capital turnover rate is a very common index that's used by the CFO and some other finance guys. That means this is very basic. Capital turnover rate is annual rate divided by the stockholders' equity, the net worth. That means if you have any amount, worth should mean the human resources, the materials, and everything. So if you have some amount of the resources, so how to create the next value? That is a capital turnover rate, and that's actually value should vary in the type of business. So that used to be the 1.3 to the 3.5. So this is a financial world. So I try to use the same methodology to the software. So software, if you like a new software, so I want to ask how much of a code you reuse from the previous stuff that are given from the other parties. So now I can calculate mathematically how much code was reused, because you can make some mathematical calculation to make some index and compare how different it is. So you can calculate the software the capital turnover rate. So this is a very important index, and I want to make some clear how did you reuse the code. This is very important things because now OEM and Tier 1 is writing quite a lot of code day to day, but so far today they're not almost rewriting the code because they are sharing the past experience and some value knowledge, but they not use the exact code. So I want to make the reusable code. So what is the strategy for that? So maybe this is my today's most important message is don't optimize the code. Of course, you can write a smart code, clean code, but don't optimize because optimization is rely on some assumptions. Assumption means a hardware configuration assumption like how many processor core, how many memory, how many channels is used. And also it rely on the use case expectation. So how many users use at the same time and how many input comes. So this kind of various assumption leads the optimization. So if you make the optimization, that result is very hard to reuse the code in a different way. So maybe some people confuse because as I introduced our hardware guys, people like to optimize the software and also the hardware because they think that's a good thing. But if you consider to reuse the software asset, that must be not optimized. And also other things like the coding convention, the style format, and readability, and the nomenclature, that kind of stuff must be considered because I am the open source guy, mostly working with the Linux kernel space over 15 years. So in the Linux kernels, there are strict style guide because thousands of different developers writing for the one kernels. So that must be follow the similar coding convention. So this is strictly defined for now. So this kind of some rules to be applied to create the reusable software. And importantly, the open source software is not optimized because open source software is written to reuse, so different use case by default. The Linux is a typical examples. And the organization like Covesa is also chasing the kind of open source way because we want to make some unified code to be applied any different kind of use case. This is the important aspect of open source. Okay. Then, so what Covesa can contribute to this kind of thing? Because as you can see today, and So Kobesa has a many important activity happening right now. The one is a data expert group. This is mostly driving the VSS, vehicle signal specification. It's a data set of common, some kind of naming for the vehicle features. And also common interface, so the vehicle API, the many VISS, many things are happening, and the data expert group. So these activities are driven by the Renesas Steve, he's driving these activities. And Automotive AOSP app framework this morning happened this room. This is led by the BMW and the GM folks and also Faurecia people right now. So making the better ecosystem to utilize the AOSP based open source. Because currently the app developer need to work each different OEM for now, making some commonality based on that one. So the Kobesa is a place making this happen in the AOSP app framework things. And the right-hand side is the electric vehicle charging expert group. This is led by the Ford folks. And as previous some panel discussions, they're thinking about how you can make a common way to utilize the charging optimization. This must be work also across the OEM, not only, but also the IT companies and the telecom company need to work together based on some common definition. So this is the major activity happening in Kobesa. And I try to support this activity for making software as a capitals. Okay, at this time I want to switch over to Dan, because Dan is following what Renesas is doing for making this happen.
Thank you very much. Thanks for the time, everybody. So I've had a lot of jobs at Renesas. I've been there almost a decade, but my latest job is overall ownership of the next-gen silicon, including the hardware, the software, and the system aspect. So Munakata-san asked me to participate in this thought leadership event, and I said, no, I'm not going to do that. What would I have to contribute to this conversation? Munakata-san is kind of our North Star of software strategy, but I checked out his slides, and they resonated with me from my Tier 1 days. So my background is production software development at Tier 1s, local Tier 1s. And when I did that, the team complained frequently and loudly that they felt that we were being rushed into the development of the software. They said, why are we always focused on, getting this done on time and getting it done faster and find the bugs, fix them right now? Why can't we slow down a little bit and think about the quality and think about open source and standardization and just taking a more careful approach to what we're doing? And I didn't know it at the time. I didn't have this term in my head, but what they were effectively saying is, we're frustrated that our development is treated like an asset and not like the software capital that Munakata-san is explaining. So if I had known that at the time, I would have been able to explain it better. But therefore, the topic here and the concept of software capitalization was sort of something that was strong in my mind. So I said, okay, let's collaborate a little bit. So what I'm going to talk about is how Renesas will implement this sort of transition to software capitalization. Munakata-san has shared some of these high-level ideas, but what are we going to do to make this happen? So I picked basically 3 items from his slides that were sort of actionable things that need to be done. So creating a software reinvestment strategy. Okay, you've made some software, maybe it's pretty good. What do you do with it now? How does that help you grow, and how do you capitalize that? The second is eliminating assumptions or managing assumptions is maybe what I would say. And the third is improving industry collaboration. So then what we did is we took those and mapped them to development pillars. So this is 3 development pillars that we're going to use in our next-gen semiconductor products from the software side that are going to help us achieve this capitalization. So single mainline development, cloud-native development, and simulation-enabled development. And then through all of those, increase standardization through consortium and OSS leadership and participation. Kobesa and AGL are 2 of those, but Renesas is engaged in quite a few of these things. So the first pillar here that we'll talk about is the single mainline development. So this sounds kind of goofy because you think, yeah, what else would we do, right, when developing software? But in reality, the right-hand side is a picture, sort of a representative image of all of the software that Renesas needs to deliver as part of a chipset. And this has grown over time. It used to be that semi-vendors could just deliver like MCAL and BSP and then we'd be done and move on. But now, over time, the OEMs say, what else you got? Where's the rest of your software? Do you have the full stack? So what it turns into for me, the way I view this, is a cradle. turns into something that we make that can hold the OEM applications, what they consider to be differentiating. So we don't want to step on their toes and get in their way and say, well, we've got a, I don't know, parking stack, or we've got a DMS stack. But we want to say, we've got everything else you need. Just take your software, drop it on top. That's your differentiation, and you're good to go. So all of this has to be integrated into a single mainline, because if you work on these things in a silo, you make strange assumptions about optimization, which then hurts our sort of goal to reuse this software in a very flexible way moving forward. So when we put all these together into what we call a single mainline, it not only takes a bunch of extra system integration test and system integration planning, but we learn a ton about the way all these components work together, and we can make better choices about where to optimize and where not to optimize, so that down the road we can use that software more intelligently. So this is sort of our first principle here. Make smart optimizations to avoid jeopardizing software reusability. The second is about cloud native development. So cloud native is sort of a buzzword within Renesas, but it's an interesting topic for us. And the way that I view this is, you can see on the right-hand side, all the way at the left it says Web UI. You can think of it like, if you're a developer, Renesas wants to provide you the easiest way possible to get to our tools, to get to somewhere where you can build and test and then analyze the software that you have to make. And this is what that is. So you can imagine, okay, here's your username and password, go to renesas.com/ whatever it is, cloud login. You log in. You start at the build stage, which is the leftmost column. The build stage is where you can take the software that you've written, drop it on top of our SDK, build it easily, use the tools that we provide related to AI, related to compiler options and all these different things, and quickly get that done. Then you go to the next stage. So the test stage in the middle is tightly connected to the third pillar, which is our simulation pillar. At the test stage, you've got an option to run it on a hill or a sill configuration. And basically, it enables you to test quickly and test in sort of a detached way from the hardware. And then from there, there's actually a third phase, which is called the analysis platform, which is actually after the software has been launched. So when it's in the field, if it has some issue, or you need to know what's going on with all the vehicles that you've launched, that analysis platform allows you to harvest data, simple data, but critical data, like what version are you running of all this software, and when did you launch it, and who built it, and blah, blah, blah. So this whole chain, from the build to test to analysis, is really built to allow more developers to access our software easier, to work with it easier, and then to pull that development left, this so-called shift left theory, where it's like, you don't need the hardware, just work pre-silicon, and then after the silicon's available, you continue to work in the same way. So this is our second development pillar that we're chasing. The third and final is the simulation and enablement. So this is a critical one, and actually on the last slide, you can see at the bottom there the target board farm. So that board farm is great if you've got the silicon and you've got the board somewhere, but even without that, we've got the simulator environment sort of on the bottom left of this image, which means we can take the virtual software package, which is basically everything that we have, the BSP, the middleware, and some application, and we can run it on a SIL environment using the simulator, or we can run it on more of an emulation environment, which is bottom right, or it could be run on a board farm that's running somewhere co-located. So the point of this is that we, again, make it super easy to access the software that we've got, and also the hardware living below it. This has been around since 2021. It's not a new concept for us, but it's evolving over time. And of course, you've got sort of on the left the functional development, and then on the right the performance-focused development. So those are the three pillars. Those are three actionable pillars that we will focus on to implement the software capitalization. So our journey is to sort of improve software capitalization for ourselves, and then enable our customers and our partners to do that on their side. So we've got sort of commitment and dedication for this transition, or this journey, from our leadership in automotive all the way up to our CEO. And this is something that we take very seriously. And after we make the journey, then we turn to our customers and our partners and say, can we help? How can we work together? What are you finding? Here's what we found, and so on. So Munakata-san shared some of these general methods: eliminate assumptions, follow coding conventions, interoperability. And then in the middle, we've got sort of the Renesas three-pillar approach. And then finally, we've got at the far right, the output, which is in theory, and I think in practice, going to be capitalized software. So that's our presentation. I think we have maybe a couple minutes for questions.
Yeah. Yeah. A couple of questions? No questions? Go ahead.
How does single mainline development work across an ecosystem? 'Cause I think I get what that looks like inside one organization, but how do you synchronize that across partners?
Yeah, I think it's a good question. I think what it looks like in my head is that when we build our single main line, right, we pull in as part of that our own assets and those assets that come from a third party, whether it be an open source like a consortium asset or could be an asset from a for-profit software shop because we think that's critical. So it's our responsibility to create our single main line and then expose the components that we make so that it may be consumed in someone else's single main line. It's also worth noting that at some point you have to customize, right? I mean, if we're selling software, we can't literally sell the same software to every OEM and tier one under the sun. So those optimizations and those tweaks happen at last. They don't happen at first. So, okay, get the whole thing working in that sort of single mainline approach and then tweak it as it goes out the door for the customers. So, but I guess it sort of becomes how are you doing it? Here's how we're doing it. Let's, see if we can help each other out here.
Yeah, practically the mainline, the pull the code, the making modification, and the merge back. Merge back is very important. So how thing happening in the Renesas is, of course, we work with the different tier one, different OEM. They feed back some information, and I merge back in the main line to share every different people's experience into the merge one. So that creates some collective value. So that is a very important. Merge back is a very important process to keep it the element fragmentation, keep it mainline. So this is already happening in the Renesas already.
And I think to that question as well, I think it shows where the importance of associations like Cavisa. So to give you one example from the past, in the IBI days, in Cavisa we had the framework that did graphic sharing. So that was largely retained by addicts. But then as an industry, we could actually talk together and we used to coordinate on the Wayland version, for example. And that's very useful because you're doing that upstream, but then downstream when that appears in an RFQ, you've already got that kind of alignment and you're not spending time then trying to change versions. So I think Cavisa, it can certainly play an important role in that, and I think this is one of the reasons why we actively participate for that kind of tier one OEM discussion.
Well said. Okay, I think we're out of time, but I know that Renesas has a presence at the showcase tonight, and I think probably everybody that is associated with the organization will be there. So if you have further questions, you can take it to the showcase tonight and take it up with these fine gentlemen. Thank you, Daniel. Thank you, Munakata-san,
No
for this
problem.
very insightful discussion.